Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so simplify fully, so a big algebraic fraction. So the first thing I do, because I'm aware I could forget it, is I take care of the division. So division in fractions always means invert the second fraction and multiply. Okay, that is how we divide fractions. Okay, and then we factorize. So the first one I'm going to do is x squared minus 9. So this one here. So that is the difference of two squares from junior cert. So x and x minus 3x plus 3. So the difference of two squares. So I will have a video on that if anybody forgets how to do it. Okay, then the bottom one. So this bottom one down here is the longest one to do. When I'm doing a quadratic that has a number in front of the x squared, like this one does, I don't use 15 as my guide number. Instead, I do 2 times 15. So it's a times c. Okay, so I would be getting the factors of plus 30, and plus 30 came from 2 by 15. Okay, so plus 30. I need them to be minus 11. Okay, so yes, 30 and 1 minus 30 minus 1 plus 15 plus 2 minus 15 minus 2, 5 and 3, not 5 and 3, 5 and 6, I should say, and minus 5 minus 6. Okay, I can stop there now because I can see that this line here adds up to the necessary minus 11. Okay, so how do I continue from there now? Well, there's a couple of more steps to it when there's a number in front of the x squared. The 2x squared stays the same. Instead of the minus 11x, I will write it as minus 6x minus 5x. Okay, now you can see that still adds up to 11. I've just written it as the sum of its factors instead. And then I'm just going to put down the plus 15 instead. And then you do grouping from junior cert. So again, what's common between the first two terms and then the second two? So I take the 2x outside and I get x minus 3. And in this one, I take the minus 5 outside and I get x minus 3 in this case. Why? Because I need a plus here, so I need a minus by minus to give me that plus. Okay, and then you group the 2 on the outside into one bracket. And then you write down the inner bracket just once. Okay, so you can see when there's a number in front of x squared, like there is in this one, the factorising takes a bit longer. So we have 2x minus 5 in that one, x minus 3. Okay, so we're multiplying that by, okay, let's factorise the top one. Okay, so let's factorize this one here. So 4x cubed minus 10x squared. So it's a cubed, it's not a quadratic, so there's no guide number or anything like that. In this one, it's taking out the highest common factor. So what's common between the term 4x cubed and 10x squared? Well, definitely the number 2 is, and then x squared. There's an x squared there, and there's an x squared built into there. So I have 2x squared on the outside. Now what must I multiply by that 2x squared to bring it up to 4x cubed? Well, I definitely need a 2 to bring it to 4, and then I need another x to bring it up to x cubed, minus I need a 5 to bring it up to 10, and I already have the x squares there. Okay, so then on the bottom we have x squared plus 3x. So again, not a quadratic. Take out the highest common factor, which in this one would be just an x. Okay, and then you hope loads of it cancels at this stage to make it easier on you. Okay, so we have a 2x minus 5, a 2x minus 5. That's good. We have an x minus 3, an x minus 3. We have an x plus 3 and an x plus 3. Okay, so at this stage I have a 2x squared over an x. Well, the x will also cancel into x squared. Remember that x squared is nothing more than x by x. So when I divide that by x, that's why I cancel the square, because you're still left with 1x. So my full answer in that case then is 2x. Okay, so you'd never think by looking at this that it would simplify all the way down to 2x. But that is the power of factorizing everything, having some cancel, and then getting your answer. Much, much easier than if you were to try and work that out without any cancelling. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.